Okay, test 5 review. I'm going to do non-repeated questions. There are 30 questions here. Form the negation of the statement. It is raining. Negation of that is it is not raining. The statement listed below is false. Let P represent the statement. The position is the antiparticle, the positron. Okay, this is positron is the antiparticle of the neutron. Express the symbolic statement negation of P. So negation of P is what can be concluded about the resulting verbal statement. If this is false, then negation of P is supposed to be true. The positron is not the antiparticle of the neutron. That is the negation. This is the only one. The positron is not the antiparticle of the neutron. What can you conclude about the resulting verbal statement? If it's false, then resulting verbal statement is supposed to be true. Where is that? Because it is the negation of the initial statement. So true because P is false. Okay, because initially P was false, so negation of P is true, supposed to be true. Express the quantified statement in an equivalent way. All buses are silver. So you need to express this in equivalent way. All buses are silver. There are no buses that are not silver. They are equivalent. And part B, which of the following is the negation? Negation of all is some. Some buses are not silver. Some buses are not silver. That's the negation. The City Council of a large northern metropolis promised its citizens that in the event of snow, all major roads connecting the city to its shelter would remain open. But the City Council did not keep its promise. That means some roads were not open. So that is the negation. So at least one major road connecting the city to shelter was not open. So at least one. That is the negation of all. Some. Okay. The bar graph shows the percentage of college students in different countries willing to marry without romantic love. So use the graph and answer this question. Use the graph to determine whether the following statement is true or false. A minority of college students in country A are willing to marry without romantic love. So country A, 46% of the population, they are willing to marry without romantic love. That means minority, and this statement is true. The statement is true because only 46%. 46%. If it's less than 50%, that's a minority. You have two statements, one P, I get an A, and one Q, I eat bananas. Write the following compound statement in symbolic form. I get an A, which is P, and symbol is this one. I don't eat bananas. It's a negation of Q. So this symbol and Q. Let P represent simple statement, the play is boring, and Q represent the stove is hot. So write the compound statement in symbolic form. The stove being hot is necessary for the play to be boring. So the play to be boring implies the stove is hot. So the play is boring, which is P, implies Q. Keep in mind, you need to reread this sentence if you do not understand. Here, stove being hot is necessary for the play to be boring. The stove being hot is necessary for the play to be boring. So the play to be boring implies stove to be hot. There are two statements. R, they raise monkeys. T, he trains dogs. So we need to write down the meaning of this. T implies negation of R. T means he trains dogs. If he trains dog, then they do not raise monkey, because negation of R is they do not raise monkey. If he trains dog, then they do not raise monkey. P, the store is open. Q, it is Saturday. We need to write it down like this. Negation of P, the store is not open if and only if it is Sunday. Not Saturday, sorry, it's a Sunday, okay? The store is not open if and only if it is Sunday. Earth is the only planet in the solar system not named after a god. So, not being named after a god is both necessary and sufficient for a planet in the solar system to be Earth. And this is true because let's say P is named after a god, planet named after a god, and Q is that planet is Earth. Then if P is not named after the god, negation of P implies Q, and Q implies negation of P. So both of them, both direction, that's true. So the statement is true. Statement does make sense. Planet in the solar system is named after a god if and only if the planet is Earth. Yes, that's right. Wait, the given statement does make sense. Sorry, not being a planet in the solar system, not being, okay? So find out not being. The statement does make sense. Let me see. What is the question? Determine whether the following statement makes sense or doesn't make sense. The statement does make sense. A planet in the solar system is not named after a god if and only. This is the right one. I choose the wrong option here. The given statement does make sense. A planet in the solar system is named after a god if and only if. No, not named after a god. I had to choose not named after a god. Look, not being after the god. So that's supposed to be true. Okay. There are two statements. P, 7 plus 10 is 17, 9 times 6 is 54. Both of them are true. So P and Q is true. That's a truth value for AND. 8 plus 10 is 17, that is false. 10 times 6 is 120, that is false either. So choose the correct truth value. If you are trying to find the AND between a statement and its negation, it's always false because one of them is supposed to be false. In this case, because Q is false and not Q is true, so true and false is false. This is the truth table we're going to create here for finding the negation of A and B. So if A is true and B is true, AND is also true, and then its negation is false. True and false is false. This AND is always false except both of them are true, okay? This is true, false, false, and negation of that supposed to be true, true. So AND of two statements, it's only true if both of them are true. There are three statements. P, prices peaked in 2000. Look at the graph and see if that is true. 2000, prices peaked, that is true. Second one, prices remained steady from 1985 through 1990. So 1985 is from here to here. It's increasing. It's not steady, so it's false. Prices were less than $2.50 per gallon in 1985. It's a less than $2.50. So P is true, R is true, Q is false. So now write the symbolic statement not P, prices did not peak in 2000, or the prices remained steady from 1985 through 1990. This one, prices did not peak in 2000, or the prices remained steady from 1985 through 1990. Since P is true, so negation of P is false, or Q is false and negation of Q is true. So false or true is always true. So using the information given that this is true, because one of them is true. Okay, what did I do wrong here? Let's go back. We would like to find the statement for this negation of P, which is prices did not peak in 2000, or Q, the prices remain steady from 1985 through 1990. Okay, prices did not peak in 2000, which is false, or prices remained steady from 1985 through 1990, which is also false. Sorry about that. Okay, false or false is false. The only situation this or statement would be false is both of them are false. I missed that part. Okay, so it's supposed to be false. Okay. The bar graph shows the careers named as probable by college freshmen. Write the statement in symbolic form. Then use the information in the graph to determine the truth value of the compound statement. More than 4.1% named career E. Career E, 4.1%. Or it is not true that 11.5% named career C. Career C. Career C. So let's say P represents more than 4.1% named career E. That's the P, which is not true because only 4.1% named career E. So P is the statement more than 4.1% named career E, and Q represents 11.5% named career C. So how do you write it down? This one is false, or it is not true. Negation of Q. Q represents 11.5% named career C. If you look at here, that's false. Negation of false is true. So if one of them is true, then our statement is always true. The statement is true. In symbolic form, the statement is more than 4.1% named career, so that's supposed to be P. Or it is not true, so it's a negation of Q. Remember, because Q is false, so negation of Q is supposed to be true. So this is the truth table. Find out the truth table for this conditional statement. If P is true, and always keep in mind this conditional statement is supposed to be false in only one situation, when true implies false. Other than that, everything else would be true. So based on that information, first of all, let's find out the negation of Q. Q is true, then negation is false. Q is false, then negation is true. Q is true, then negation is false. Q is false, then negation is true. Now look at here, true implies false. That is the only case where you have false. Other than that, true implies true also gives you true. False implies false, that is also true. False implies true, that is also true. The only case when true implies false, you need to look at here, this if statement, this conditional statement is between first column and third column. Okay, again we need to form this one first. Truth, true, and true is true. The only situation the AND statement is true if both of them are true, otherwise it's false. So I'm just going to fill out these boxes here. False, false, false. Cool, because one of them one of them is false. So the only case when our statement is false is both of them are false. Other than that, everything else would be true. So it's a true, true, true. The only case this compound statement would be false if both of them are false. So now we need to see the relation between third column and fourth column. So this conditional statement would be false only if true implies false. True implies false, but there is no way the true implying false. True implies true, and then everything else doesn't matter. So it's always true. True. You understand? The if condition is only false if true implies false. Other than that, it's always true. Okay, this is if and only if. If and only if. So let's go and check if and only if. What is that? Which compound statement? This one. This is what you have to check. What is that? Okay, biconditional statement or conditional statement that are true if the statement is still true when the, okay, if a compound statement this one, I'm trying to find out compound statement, right? Oh, it's true and false. That's the next one. Truth table for negation, conjunction, and the compound statement. That's the next. This one is the section I was looking for. Look at here. A biconditional is true only when the component statement have the same truth value. So this is what we're going to use here. If both of them have the same truth value, then it's true. A biconditional is true if both of them have the same truth values. Meaning, in this case, Q and negation of P supposed to have the same to be the true. So first of all, let's find out the negation of P. Because P is true, that's false. That's false. That's true. That's true. Now check between second column and third column. If both of them are same, then that's true. Otherwise, it's false. If you see the different type of statement for both of them, so true, true, that's true. False, false, that's true. If it's different, then that's false. That is the biconditional truth table. Same here. This is the first biconditional. So if both of them are true, then it's true. Otherwise, it's false. We are trying to find out the truth for the first one. Now, based on this, third column implies the second one. If truth implies false, only in that case it's false. Other than that, look, truth, this is the left one, and false, that's the right one. Only this case is false. Other than that, everything else, it's a true. And that's coming from, once again, this one. The only case in which the conditional is false is when the first component statement is true and then second component statement is false. If it's true implies false, then only in that case it's false. Other than that, everything else is true. Okay, write the following statement in symbolic form, then use the information in the graph to determine the truth value of each compound statement. So if there was a decrease in the percentage who believed in God, then it is not the case that there was an increase in the percentage who believed in the devil and the hell. So P stands for there was a decrease in the percentage who believed in God. So P implies there was increase in the percentage who believed in devil, which is Q, and there was increase in percentage who believed in hell, which is R. But here then it is not the case. So that means it's a negation. Negation of Q and R. If you look at here, it's a negation of increase. There is not the case there was an increase in the percentage who believed in the devil and hell. So now for finding the truth table P, look at there was a decrease in percentage who believed in God from 2003 to 2016. That's true. And then Q, which is there was increase in percentage who believed in devil, that is decrease. And then hell, that is also decrease, right? But it says increase. So false and false is false, and negation of false is true. So true implies true, that is true. Keep in mind, this implication is only false if true implies false. Other than that, it's always true. So this is a big truth table. Finding this is not difficult. So first of all, find the negation of P, meaning just opposite of P. True becomes false, true becomes false, false becomes true, false becomes true. And then this is the negation of second column. True becomes false, false becomes true, true becomes false, false becomes true. And then this is P implies a negation of Q. That means you take the relation from P and first column and then fourth column. So the only case it's false is when true implies false, so which is the first one. Other than that, just it's true implies true is true, false implies false is true, false implies true is true. All other cases are true. The only case Q implies negation of P is false when Q is true and negation of P is false. So the first case is false, and then other than that, everything else is true, true, true. Which statement below is equivalent to the given statement? If the sun is out, then it is not night. So let's P is sun is out and Q is it is night. Then this is what we have. If the sun is out, then it is not night. And based on their truth values are same. That means they are equivalent statement. So meaning, so you need to find out the this one. So Q means it is night. If it is night, then the sun is not out. If it is night, then sun is not out, because these two, based on this truth table, these two compound statements are equivalent. So the equivalent statement is this one. Okay, to create the compound truth table for this type of compound statement, you need to go through all the cases like P, Q and R, because there are 3 statements, so there will be 8 different cases for the truth value, because 2 to the power 3 is 8. 2, I choose the 2 because truth or false, So instead of drawing that truth table, I'm going to use this example truth table to show you. P, Q and R, there are 8 different cases: true, 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 false, false, true, false, true, true, false, 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 true, true, false, true, false. These are 8 different cases. Based on these 8 different cases, now you can find out AND and AND. So first find out the AND between P and R, because this is what in the example we have given. And then based on that, find, so what is the P and R? If P is true and R is true, that is true. And if this is true and then Q is true, then true and true is true. Other than that, everything else is false. You see? So we can create the value here, and then based on that, we can create this thing. Okay? And based on this information, if both of them have the same truth value, this column and this column, then they are equivalent. So If you do that, you will be able to see that actually they are equivalent because they will have same truth table, truth values. Okay, it was very time consuming but very easy problem. That's why I let you do that table thing. Write the converse inverse. So converse inverse thing, let me just go here. Where is that converse inverse? This one? No, I think this one. Yeah. Okay, converse means if you have P implies Q, then Q implies P is the converse. Inverse means negation of P implies negation of Q, and contrapositive, which is equivalent, is negation of Q implies negation of P. So you have to keep in mind that thing while answering this question here. If you are not awake, then you are not in class. What is the converse of that? Converse means if you are not in class, then you are not awake. What is the inverse? Negation of not awake is if you are awake, then negation of not in class is you are in class. What is the contrapositive? If negation of not in class, if you are in class, then you are. So what is the contrapositive? What is that? Negation of Q, negation of P. If you are, what is that? Inverse means if you are awake, you are in class. If you are awake, then you are in class. And contrapositive is if you are in class, then you are awake. That's the contrapositive, and that's the equivalent statement of that conditional statement. Very similar type of question. I'm going to, okay. So express the statement given below in if-then form. All fires burn. All fires burn. If it does not burn, then so what is if? It is a fire, then it burns. If it burns, then it is a fire. All fires burn. So here, okay, when I click it, it just showed me the completed one. So let me just click another one. All governors are politicians. If someone is, all governors are politicians. If someone is a governor, then he or she is a politician. This is how we can write if statement. If someone is a governor, then he or she is a politician. Which statement below is correct converse? Converse means, if you go here, converse is just reverse that. So that means if he or she is a politician, if, what is that? Converse, if someone is not a politician, if someone is a politician, then he or she is a governor. That's the converse. What is the inverse? Inverse means if someone is not a governor, then he or she is not a politician. And contrapositive is if someone is not a politician, then contrapositive, then he or she, if someone is a governor, then he or she is a politician. No, this is the inverse. So inverse is negation. So what is the negation of this first statement? If someone is not politician, then he or she is not a governor. And what is the contrapositive? Contrapositive is if someone is not a politician, if someone is not a politician, then he or she is not a governor. I did miss something here while clicking the answer. So let me go back. All governors are politicians. If someone is a governor, then he or she is a politician. Okay. What is the converse? If someone is a politician, then he or she is a governor. What is the inverse? If someone is not a governor, if someone is a governor, inverse means negation. If someone is not a governor, then he or she is not a politician. Yeah, that's the mistake I did while clicking to the next problem. Okay, let's go to the question number 25. Okay, sound intensity is measured in decibels, dB, that's the units. Sounds louder than 85 dB can damage a person's hearing if they go on for too long. The bar graph shows the intensity of sound for 6 selected sources of sound. As you can see here, airplane takeoff, the sound intensity is 119 dB, chainsaw 119, subway 101, and then so on. Consider the following statement. If the source is a normal conversation, the sound level is not 101 dB. Normal conversation, the sound intensity is 57, so this is correct statement. So complete part A and B. Use the information given by the graph to determine the truth value of the following conditional statement. The truth value of the conditional statement: if the source is a normal conversation, the sound level is not 101 is true. That's right. Write the converse. Converse means opposite. If the sound level is not 101 dB, if the sound level is not 101 dB, then the source is a normal conversion. That's the converse. Okay, and the truth, we cannot say anything about the truth because we don't know the relation between the truth table between these two. They are not equivalent, so not necessarily true. We don't know. Choose the correct choice below that state the inverse. Inverse means not the first statement, implies not the second statement. So not, if the source is not normal conversation, then the sound level is 100 and the sound level is 101 dB, because not of not is, negation of not is without not. Okay, so the inverse is if the source is not a normal conversation. And once again, we don't necessarily know the truth value, so we don't know the necessarily truth value. Only case we know the truth value is contrapositive, because contrapositive and this statement is equivalent. Contrapositive is not the sound level, the second negation of the second statement, which is if the sound level is 101 then the source is normal conversation. Normal. If the source is normal conversation, if the sound level is 101 the source is not the normal conversation. Yes, so negation of this implies negation of this. That's a contrapositive. And if it's true, then its contrapositive is also true because they are equivalent. Write the negation of the conditional statement. If it is turquoise, then it is not a radish. I don't know how to pronounce this. Turquoise, then it is not a radish. What is the negation of that? Negation of conditional statement is the first statement and negation of the second one. So it is turquoise and negation of this is it is a radish. This one. De Morgan's law to write a statement that is equivalent to the following statement. It is not true that the aunt and uncle are both married. So negation of the aunt is married and then uncle is married. Negation of and is or. So negation of the aunt is not married or the uncle is not married. So that's because of from the De Morgan's law. Again, if you want to implement the negation for or, it's supposed to be and. So negation of Q and negation of P, which is actually P. So and, this is the right one. using the De Morgan's law. The bar graph to the right shows 6 leading causes of death in a certain country along with the average number of days of life lost for each hazard. Complete part A through C below for the following statement. Being in a fire reduces life expectancy by 19 days. So these are the life expectancy reduce because of this incidents. Being in a fire 19 days, that's true. And cancer reduces 1107 days, that is also true. So true and true is true. So use the information given the graph. The statement is true because true and true is true. Write the compound statement negation. So negation of and is negation of the first one or negation of the second one. So what is the negation of being in a fire? So reduces, does not reduces. Being in a fire does not reduces life expectancy by 90 days, or cancer does not reduces life expectancy by 1107. So this is the right one because negation of and supposed to be or, and then negation of the first statement or the negation of the second statement. So that is right. So if the statement itself is true, then its negation is supposed to be false. Use the graph in the truth value for the negation. Okay, so false or false is false. Finally, this is also very similar question like 29. You just look at the graph and find out the negation. So I'm going to skip this. So that's all for test 5 review.